Alright, welcome to part 2. We're going to finish up this little problem right here. When we last left the TARDIS, it was bouncing up and down like a Mad Hatter. So anyway, the TARDIS has an average speed. We want to find the average speed of the TARDIS between 3 and 5 minutes. We call this the average rate of change, or what we like to call AROC. Now this comes from honestly, this is very simple to do. If I'm looking for the average rate of change, that's just the slope. Now we all know that slope is a change in y over change in x, but in calculus we like to, nerd it up a little bit. So we're going to say this is the change in the y values at b minus the change in the y values at a. So at the value of the function at b minus the value of the function at a. That's the change in y over the change in x, b minus a. So to get this on the calculator, let me clear that out. To get this on the calculator, very simple. To get the average rate of change, what we're going to do is we're going to find the value at 5, so we call that f of 5. We like to write it this way, minus the value at 3, all over 5 minus 3. So we have to find the values. To do that on the calculator, remember, you can go to Menu, you can go 5 for trace, and then 1 for graph trace. Just type in 5. It shows up there on the screen. Press Enter. And it gives me this value, 300.197. So we're going to get 300.197 minus, now I want the value at 3 without typing anything else. Just type the number 3. I press Enter. See, it shows up on the screen. I press Enter, and it gives me this negative 32.589. And I'm going to go ahead and write that down. Ran out of room there. Negative 32.589. And I'm going to divide that by 2. My last thing we do, I'm just going to go ahead and calculate that. So if I just go press this little button right here, it just gives me to the scratch pad, which I like. And I just type that in. Cool thing about the calculator, if you ever just hit Control and divide, it makes a fraction for you. 300.197 plus, because two negatives make a positive, 32.589. And I put that all over 2, and we get 166.393. Now let's talk about the units. Remember, my y value is a change in my function, and the function was measured in feet. Over at the bottom is my change in time, minutes. So this is about 166.393 feet per minute. Now the cool part about the calculator is this one. Find the instantaneous rate of change. This is what we call the instantaneous rate of change, or IROC. This is the derivative. Now, the derivative does find slope, but the derivative is a slope at 1 point. Notice, up here we said between 3 and 5. Down here we want the slope at exactly 4 minutes. So this is our derivative. In other words, we're trying to find h prime of 4. So if I'm looking for h prime of 4, to type that in the calculator, we know this. This is the derivative. You go to Menu, Analyze Graph. You're looking for dy dx, 5, and I just type in the number 4. Press, hit the graph. See, it asked me to hit graph, because I have 2 graphs on there now, so I need to hit the graph. So I'm going to highlight the blue. I just press Enter. Now it asks me for the position, and now I can just type in my 4. There it is. See, there's a 4. You can kind of see where the 4 is right there. Press Enter, and it gives me that 197.741. And again, this will be in feet per minute. With the derivative, for now, we just got to kind of remember that there is a unit, that it is a rate of change. It's going to be feet per minute. These both find slope, but remember, the AROC requires 2 points. It's a slope. The derivative, IROC, the instantaneous rate of change, requires only 1 point. All right. So we're mathematicians. We love to party. So let's take a look down here. The next one says, name 2 times when the velocity, the IROC, instantaneous, is 0 feet per minute. This is kind of cool. We're just basically looking for where the slope is 0. That's what this says, where the slope is 0. And you can look at the graph. On the graph, these are just your max and mins. So, ready? these are your max and your mins. So I'm going to find one minimum. See down here, my slope is 0. Up here, my slope is 0. So to find a max, you're going to go to Menu, Analyze, go Menu, Analyze, go to Analyze, 6, and oh look, there it is! Maximum mathematics, or maximum effort. So there we go. I just go to maximum, hit enter, and the cool thing is, if I hit enter, it just says graph. Whoop, it says graph again down here. So we're going to highlight the blue graph, and it says lower bound. So this is my maximum. I want to find this maximum. So I'm just going to, oh, sorry, screwed over. I'm going to just press that button, and then it says upper bound, and I'm going to scroll over, and there it is. There's my maximum value. And it highlights. Now notice when I kind of go through here, watch. Wrong way. Wrong way. There we go. When I go through here, look, oh look, I'm not at the top, but there's my maximum value, 5.2. And then once I pass the maximum, it won't change. So we get, so my first maximum, my maximum value is at t equals 5.7212 minutes. And now I'm going to find my minimum, a minimum value. To do the minimum, same thing, Menu, Analyze graph, go to minimum, press enter. Now, whoops, escape. Sorry, let me escape it. Let's do that again. Now, sometimes if you don't like all this stuff, highlight it. Highlight it. Not working. There we go. There we go. Almost. There it goes. Delete, and it kind of goes away. Okay. Okay, and you know what? There it goes. Highlights it. Press delete, and they can go away. So if your screen's too cluttered, you can just highlight things like so, and just hit delete, and they go away. Don't like the point? You can get rid of that too. All right, there's my minimum value down here. So I'm going to go Menu, Analyze graph, but this time I'm going to hit minimum, enter. Now it says which graph again? So I press the blue one. That's what I'm interested in. Lower bound. I go scroll until it gets to me the lower bound right there. And there it is at t equals 2.5796 minutes. And there we go. Hard to see there. So hit clear, get out of there, and let's do to the last question. Right, what is the equation of the tangent line? Now these are big. To get a tangent line, there are two things we need. One, we need a point. And two, we need the slope. Now the point is easy. This is just going to be h of 8. It's the value. If you remember to get the value, this is my value. So I go Menu, Trace, 5, Graph Trace, and I just type in the number. Whoops. You know what? Let's get rid of this equation right here. Delete, delete, enter. There we go. Now go Menu, Trace, Graph Trace, and I just type in the number 8. There it is. X is equal to 8 down there. Press enter, and it gives me 19.942. To get the slope, that's our derivative, h prime of 8. This is our derivative. So if I type in that, Menu, Trace, Analyze graph, 6, and we go to the derivative, number 5. I just type in the number 8 again, press enter, and it gives me negative 151.94. So my point is 8, 19.942. My slope, negative 151.94. So my tangent line, oh no, I ran out of room. Y minus 19.942 equals negative 151.94 x minus 8. Ugh, ran out of room down there, just at the very end. And there's my tangent line, right down there, kind of hard to see. There we go. I'll put attention to it. Tangent line. Alright, well I hope you enjoyed the video. I hope this is helpful for you, and I'll see you all in class, and then see you later. Bye-bye.